Alright, so we are going to start with our first number system that we're going to look at here, and that is the binary number system for digital electronics, and it is a base 2 number system, meaning that there's only two possibilities, either a 0 or a 1. That's it. So if you have not done so already, go through on Blackboard and look at my notes that I posted about the binary number system, because it goes into more detail about the specifics of the number system. So to save on time, I'm not going to get into that. All we're going to focus on here is looking first off at counting, how to count in binary, go through the sequence of that, and then look at how to convert binary numbers to decimal numbers. Alright, so if you have not done so already, again, go look at those notes first and then come back to watch this video. Alright, so jumping right into things here, we're going to first look at counting in binary. Alright, so to start off with over here, I'm just going to do a side-by-side comparison to show you the binary numbers and then what its equivalent is in decimal. So again, 0 and 1 is our only options in binary. So when we're comparing that to decimal, that's where the similarities of the two number systems end. Alright, because after that everything is different. So 1 in binary is basically like 9 in our decimal system. So when you're counting in decimal, 0 through 9, that's as far as you can go in one place value. Then you have to add another place value. Well, in binary, 1 is like that 9. So after I count 1 to go to 2, I make this first place value a 0, and then I go into another place value. So 1 0 in binary is worth 2 in decimal. Okay, so that is not 10. That is 1 0, which in decimal is 2. Alright, so the key to counting in binary is finding the first available place value where you can add in a 1. So you need to work from right to left to do this. Alright, so the next number, the first place value is a 0, so I can add my 1 right there. Once I add that value, everything to the left stays the same. So 1 1 is 3. For the next one, I'm again looking for the first available place value. So this one has a 1. Again, that's like our 9. So that goes to 0. That's a 1. So that goes to 0. So now I have to add a third place value, and that is 4. Again, find that first available spot. So that's right there on the first place value. Everything to the left stays the same. So 1 0 1 is 5. Next, this place value is full. I can add 1 in the second place value. The third one drops down. So that is a binary 6. First place value is empty. I can put my 1 right there. These two stay the same. So that is 7. This one's full, goes to 0. This place value is full, goes to 0. This place value is full, goes to 0. So now I need a fourth place value, and that is 8 in decimal. Alright, so the first one's empty. Put my 1 right there. Everything else drops down. That's 9. This one's full, so it goes to a 0. That one's empty. I can add my 1. These two come down. So that is 10. This one's empty. Put my 1 right there. Everything drops down. So that is 11. These two are full, so these go to 0. This one, I can add my 1. This one drops down. So that is 12. Okay? So that's how the sequence works for counting numbers in binary. Alright, so I'm going to jump on over here to the right side of the page where I've just started at a random binary number, and basically say start counting from that point. Start counting 20 spaces. Not going to do all that here on this video to save time. Alright, but again, working from right to left, I look for the first available spot. I can add in a 1. So the first place value is a 0. I can add my 1 right there. Everything to the left just comes down. So 1, 1, 0, 1, 1. Alright, so for the next one, this one's full. So it goes to 0. This one's full. It goes to 0. This one's full. It goes to 0. I can add 1 right there. These two come down. First one's empty. Put in my 1. Everything else to the left stays the same. This one's full. Goes to 0. I can add it in the second place. Everything to the left stays the same. First one's empty. I can put my 1 right there. Everything to the left stays the same. Okay, so your point at where things change and where things stay the same just depend on where you're at in the sequence. So the next one here, the first place value is full. That goes to a 0. That one's full, goes to a 0. That one's empty. Put a 1 there. Everything to the left stays the same. First one's empty, so I can put my 1 right there. Everything to the left stays the same. The next one, this one's full, goes to a 0. Add 1 here. Everything to the left stays the same. First one's empty. Put my 1 right there. Everything to the left stays the same. Alright, so now I have 6 1s here. So what does that mean? Since all these are full, I'm going to need 1 more place value. So all these are going to go to 0. And I add 1 more place value out here. Okay? So that's the sequence. Again, finding that first place where you can add in that 1. Then everything else to the left of that stays the same. Alright, so I'm just going to stop it right there to save time. If you want to work the rest of these on your own and practice that, you can do that. Alright, so now let's jump into converting binary numbers. Alright, so we're going to look at converting from binary to decimal, and then we'll look at converting from decimal back to binary. Alright, so to do this, the key to doing this is using the binary number line, which is right here. Okay, so this is what will make it real easy for us to find the equivalent of this binary number. Alright, so the binary number line just goes 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, and on we could go. Alright, so it's just like any other number line. It goes on forever. Alright, so it's pretty easy to remember because it doubles. So this represents each place value of the binary number. So much like in decimal where we say ones, tens, hundreds, thousands, in binary it's 1, 2, 4, 8. So because it's a different base value, each place value is worth differently than in our decimal system. Alright, so to find out what this decimal equivalent is, we are going to take this binary number and place it under this number line. So my first example is 1001. So 1001. Okay. So now to find the decimal value, all I have to do is add up where the ones are. Okay, so I look at the numbers above the ones, and that is what I'm looking for. So I have a 1 in the 8's place and a 1 in the 1's place. So 8 and 1 is 9. Alright? And that's my answer. That's my decimal value. So 1001 in binary is worth 9 in decimal. Alright, let's look at our next example. So it is 1 0 1 0 1. So again, I look at where the ones are and add up those values. So I have a 1 in the 16s place, a 1 in the 4s place, and a 1 in the 1s place. So 16 and 4 is 20. One more is 21. So that's my answer. Alright, so the next one, I have 4 1s and a 0. Alright, so I've got 16 and 8, which is 24. 4 more is 28, and 2 more is 30. And that's my answer. Alright, and then the last one here, and I'll come down here because I'm running out of room. So that's 1 0 1 1, 3 zeros, and then a 1. Alright, so I have a 1 in the 64 place, a 1 in the 8s place, a 1 in the 4s place, and a 1 in the 1s place. Alright, so I have 64 and 8, which will be 72, plus 4 is 76, plus 1 is 77. Okay, so that's just a few examples to show you how to convert a binary number into a decimal number. So again, just write out your binary number line, place the binary number under that number line, and then add up where the ones are, because you only count the ones. The zeros are just placeholders. Alright, so next we're going to look at the decimal conversion back to binary. And we're basically just going to take the reverse approach. So we're still going to utilize our binary number line, which I have down here. But instead of adding, we're going to be subtracting. Okay, so here I've got some examples of just some decimal numbers, and we're going to convert that to binary. Alright, so I look at my number here that I'm using, which is 18, and I look at my number line. Alright, so I don't have 18 on that number line. Alright, so what I have to do then is find the largest number that I can subtract from that decimal number without going over. Alright, so 32 is too big, 16 I can subtract from that. So that's my starting point, is 16. So I will put a 1 under that 16. So 16 from 18 leaves me with 2. Alright, so I'm just subtracting this out. So 8 I cannot subtract from 2, so it gets a 0. 4 I cannot subtract from 2, so it gets a 0. 2 I can subtract from 2, and that puts me at 0. So the ones place there gets a 0 to hold that value. So that is my answer. 1 0 0 1 0. So 18 in decimal is worth 1 0 0 1 0 in binary. Alright, so the next one is 27. 32 is again too big, so I'll start at 16. So 16 from 27 gives me 11. I can subtract 8 from 11, and that leaves me with 3. So 4 is too big. 2 from 3 leaves me with 1. 1 from 1 leaves me with 0. So that is my answer. 1 1 0 1 1. Alright, the next one, 42. So 64 is too big. So 32 will be my starting point for this one. Alright, so 32 from 42 leaves me with 10. So 16 is too big, but I can subtract 8 from 10, and that leaves me with 2. So 4 is too big. I can subtract 2 from 2, and then a 0 for a placeholder. So that's my answer for that one. 1 0 1 0 1 0. Alright, then my last one is 88. So I can subtract 64 from 88 because 128 is going to be too big. So 64 from 88. And that leaves me with 24. So 32 is too big. I can subtract 16 from 24. And that leaves me with 8. So 8 from 8 leaves me with 0. So the rest of these are zeros. So that is my answer for that. So 1 0 1 1 0 0 0 is my answer for that. Okay, so that's how we convert from decimal to binary. And by the way, I wanted to mention also the subscript numbers, and that's just to indicate what number systems that we're talking about. So you'll see these as we go through the videos. So I've got a 10 here to tell me that these are decimal numbers, and the 2's here are telling me I'm converting to binary, and vice versa up here. So you'll see those subscript numbers to indicate what base value number system that we're in. Alright, well, hopefully this helps and gives you a pretty good idea of how to count and convert binary numbers. Again, look at those notes on Blackboard, and if you have any questions, let me know. Alright, thank you.